Hi, guys. Sorry, I was a little late. Can you guys hear me okay?
Morning, Suji.
Good morning, good morning. Yeah, so just when I was about to start the meeting, my computer decided to restart. So anyway, so we are here. All right, guys, good to see everybody here. Let me get set up real quick. Give me just one moment.
Sorry, I'm late. I was wondering if I was a little late, but
no, I don't know. You're fine because I'm late. So, so I guess we're all good. All right, guys, give me 1 minute. I need to restart everything here because my computer just decided to restart. Anyway, go ahead, guys. How's everyone doing?
Suji, I like the cat behind you.
That's that's right. Oh, you can see me, right? Exactly. Yeah, yeah. So yes, that's our cat. He usually comes around here this time, but okay, I'll show him to you guys if he's around. All right, guys, let me share my screen. We have a lot of things to go over today. I want to get going real quick. How's everyone doing? Any questions, comments? How are the exercises going? So let's talk about that a little bit real quick. Go ahead, please. Yeah. Are you guys finding the exercises okay? Just at right difficulty?
So I started just this week, and I'm catching up. I still have more to cover, but I feel like they're really good. I mean, it's not too detailed at the same time. It's not too high level. It's kind of nice.
Right, exactly. And initially, kind of right. If you can see my screen here, right? Excuse me. Like this is a learning path we are following. So if you look at this, basically, right now we are kind of doing the prerequisites, right? So so the pandas, numpys. So we don't need to get like a, I don't need to get a PhD in pandas. I just want like the basics. So that I need for the machine learning. That's what we're up to right now, right? So and if you look at like pandas and numpy, there are books written about how to really use these guys to really advanced extent. We don't need that. Okay, so glad to hear it.
One question, Suji. So are you planning to give like a homework pause or something for 1 week in between sometime just to catch it?
Yeah, so sorry, are you asking like so every week I'm assigning a section, a couple of sections.
Give a pause for like 1 week and just let everyone catch up with what's going on.
I am okay, right? Again, so yeah, so kind of the way, I kind of want to do, for example, right? If you look at this, like for example, let's say, some people wrote me and say, hey, they say, I know Python pretty well. Can I skip this week? That's perfectly okay, right? I mean, the goal for, that week was basically, if you look at the sort of the weekly curriculum here, right, is, right, first week is all about Python. So if you know Python already, you could easily skip this. And then same as here, right? We did pandas and the NumPy last week and pandas this week. So if you are familiar with all this, completely okay to skip, right? And catch up, right? So let's say you're going to a little behind. Just try to catch up. And like I said, we'll sort of go, because I don't want to sort of lose too much time either, because we are kind of, right, in the prerequisite stage, right? I don't want to spend too much time here. So I kind of want to keep you guys moving once you go to machine learning. And then maybe we can do like, I like your idea of taking like a 1 week break in between just to kind of, right, have everybody catch up. Right. Yeah, I like that idea. We'll definitely do that. All right, guys. So I also looked into just kind of logistics here. How this course can advertise. So basically, we advertise this course in like like meetups, right? It's like it's on LinkedIn, right? It's advertised in a lot of places. Basically, everything points to Eventbrite, right? So wherever, it doesn't matter where you see it, you basically come to Eventbrite to sign up, right? And then from Eventbrite, once you sign in, basically, you come to sort of the Google Doc, right? So when you sign up to Eventbrite, you come to the sort of the Google, right, our Google Doc system we are using. So that's how it is designed. Basically, because we this is being promoted in many places. So Eventbrite is sort of this registration, and when you sign up for Eventbrite, you get a link to join the Google Doc, right? Basically, right? And then the Google Doc, you guys been using this all along, right? This one has all the links. So this is kind of what we, how it's working, and I don't know. I mean, this is what we could come up with. If somebody has a better idea, we could definitely do it. But basically, right? Doesn't matter where you hear about it. Like, for example, this goes out right on our website as well, right? So people come to a website, they sign up. So everyone signs through Eventbrite because that's the platform we use. And then once you're signed in, you send your link to the Google Doc. So anyway, so I thought that was reasonably okay, but there's a better way of doing this. I can hear I'm open to suggestions, right? All right, guys. So any other concerns before we get started? Also, I want to make sure if you guys are able to sign in using your groups. I highly recommend it if you can work as a group, right? So I see people are signing up already. So find a group near you guys in your time zone. Please work as a group, right? Because it'll kind of keep you motivated, and also you'll get the help also, right? So I sincerely hope you guys actually join a group. Good, guys. So what I want to do today, right? If you look at the curriculum, I am going to go through some of the solutions you guys have done. So if you look at this one, guided machine learning curriculum, so you already see I have my solutions posted, right? And I'm going to also share with the class submissions as well. So let me go through them real quick. Right, again, these are like, just click on this link, just open in Google Colab, right? So, and you will see these are solutions for the, for the last week exercises, right? And everyone cannot get to this. So from your welcome guide, right? Basically, you want to come to the, right? The, class curriculum, right? And then from there, for each week, right? The solutions are. I also opened up the solutions you get submitted for last week as well, right? So if, for example, we click on this one, you should be able to see all the submissions, right? For the Python data structures. Yeah. So again, you feel free to kind of, if you want to share with somebody, you can say, hey, my solution is here, and then you can give them their link, and they can load up straight away into Colab. Yeah. So that's how I plan to share this, guys, because like I said, yeah, I will provide some solutions, but I also want you guys to learn from others as well. Does that make sense, guys? Right? Are you guys able to access these? Yeah. Good. So let me talk about Pandas solutions real quick. So this is again, this is mine, right? Again, this is not the only way of doing this, but this is at least get you guys started. So again, you sort of match the number, right? So for example, we are using the workbook here, the same workbook is following. So we're doing like A1, A2, A3, right? Same style. So very quickly, right? Again, actually, yeah, can you guys access the machine? By the way, if you want to run this notebook, I think what Google recommends is save a copy of your own in your own drive. So what you have to do is you have to go to File. You simply say save a copy, all right? Because right now what you're looking at is a shared notebook, right? And I don't think they will let you run this. Because I can run it because this is in my account. So what you want to do is like again, so when you click on the solution file right here, right, it'll take you to the Colab directory. And what you want to do is you want to simply say save a copy in your drive. You can do that, right? Also, or you can download. Like for example, let's say you're running Jupyter in your locally, you can download the IPython notebook as well, right? And just a Jupyter notebook. Okay, so definitely if you're running Colab, please save a copy and then use that copy, right? Because otherwise I don't think you'll be able to run my notebook because that's read only. All right, guys, so take a look again, these are like, trivial stuff, import pandas, right? And this version command you guys probably figured out by now. This is a fairly standard for Python. Modules will say __ version. Right, that's a standard Python thing. So if you're curious about any modules version number, they pretty much support it, right? __ version. And this is sometimes important because sometimes you're looking at modules and there are some conflicts. So you will say, I need like version 1.5, How do you know for sure, right? So you know for sure, like here. Okay. Creating a data frame, pretty straightforward. So basically, the way you have to think about this is like this, right? If you understood this, it'll make sense. Sorry guys, can you go on mute, please? There's a lot of noise on the line. Guys, if you don't mind, please go on mute. All right. All right, guys. So creating a Pandas data frame goes like this. Just remember the syntax, and you'll be fine. By the way, can everybody see my screen? Okay. Yeah. So creating a Pandas data frame, you simply do this like this, right? You're going to give, right, a dictionary, right? And this in this dictionary, actually, let me do this right. This way easier. So in the dictionary, what does the dictionary look like? You're going to have a column name. Let's say column 1 name, whatever that is, right? Well, in Python, as you guys did this yesterday in the dictionaries, we do key value pairs, right? So key 1, value 1, that's how the dictionaries are formed, right? Key 2, value 2. So key here is column name, basically, right? And the value is basically all the values of the column, right? Say whatever the column names are. You guys got that? Okay, comma. Next key value pair. What's the next key value pair? Okay, column 2 name. And let's say the column, column 2 values, right? Whatever that is. That's it, right? This may seem a little mysterious, but once you guys understand this format, so it's basically you're passing a dictionary with a key value format, right? Key is the column name. So you have to think like this, right? You have to think like an Excel spreadsheet, right? If you're doing a key value pair, let me do a new one here, right? Give me a sec. All right, so kind of like this, all right? So this is your Pandas column 1, column 2. These are your values, 1, 2, and 3, A, B, C. That's it. Sorry. All right. So once you guys understand this, the Pandas constructs will make a lot of sense. Does that make sense, guys? Right? Just key value pairs, key is column name, entire column values, column 2 name, column 2 values, right? So on and so forth. That's it. Right? Now, usually you're not going to be, reading your Pandas data frame using this. You'll only do this for like small data frames. Usually you're going to be reading from like file, right? And that's what the next exercise, showing you guys. Does this make sense, guys? Kind of right? How we, how we sort of envision this? Right?
Suji, I have a question. Maybe I'm jumping ahead here, but so at what stage you would actually look into the data and do any cleanups, like if there are garbage in there?
Well, actually, yeah, that's actually this week, right? Yeah, this week's assignment we're going to be looking at data loading and data cleanup and all that. Yep. Right. So I want to do it. So if you look at the curriculum a little bit, so I want to look at stats and data. So EDA, Explorer Data Analytics, is where we sort of start looking at looking into the data and analyze data. Yeah. So what we are sort of building up is based on some of the basics that will allow us to do that. Make sense? Yeah, exactly. All right, so that's how we create Pandas data frame, right? Basically, think of it like this, right? We're spreading columns and column values. That's it. Okay. And so index and slicing, this is again, it takes a little getting used to. There are like so many ways of doing this. I just want you guys to know the basics, right? We don't need to go get like a PhD in this one, because there are, if you look at Pandas, like if you look at Pandas cookbooks and things like this, there are a lot of different ways of doing this, but we just want to know the basics, right? So typically, when you have a data frame, so this is my cities data frame, right? So let me execute that. Right? That's my cities data frame. So it says, right, city, population, rainfall. Now, one thing you will see is like this index on the very left-hand side. This is like row number. Remember in Excel spreadsheet, if you look at the Excel spreadsheet, see the row number 1, 2, 3, 4. It's part of Excel spreadsheet, but not part of the data. See what I'm saying, right? So if you say something like, okay, can you select me row 3, right? That's row 3. That's just a row index, that's it, right? Because that sometimes confuses people. So think of like a row index, right? And of course, everything starts on 0, right? So you start, in an Excel spreadsheet, we start at 1, here we start at 0. Anywho, right, that's that. So if you have a data frame, when you say a column name, right, you're gonna get the entire column, right? So I said, so show me the population. So you can see, right, it's gonna give me the population column, right, along with the index, the row index, right? So, and also you can print out like this too. This is called index location, right? So, and this is what the syntax you guys are kind of mastering the, on the previous labs. Remember when we were doing the lists, if you remember, right? And also NumPy, remember? This syntax, colon, comma, all this stuff. This is basically the same NumPy slicing, right? So think like NumPy matrix slicing, right? So it'll come in handy. So if you're a little rusty on this one, go back and look at the NumPy slicing, right? In the NumPy, we have a slicing. I think I have one section on the entire slicing of NumPy arrays and matrices, right? So it's called slicing. Do I have this one? Indexing and yeah, right? Indexing basically, yeah, indexing and slicing, right? Anyhow, so that's where you guys can, so kind of you can see how everything's kind of building towards, right? So this notation is pretty universal. All right. So again, the syntax is row and column, right? So San Francisco, if you look at the San Francisco is row number 1. So the syntax basically says, right? Let's say I print out San Francisco, right? Row number 1, 1 comma basically meaning that's it, right? Row and everything, right? So row 1, this basically means, the syntax means, print out all the columns. So it prints out all the columns for the city population rainfall. Again, the syntax, don't get lost in the syntax here. This is just how the slicing syntax works. So again, to take a look at this, the NumPy section, to do like a refresher, right? Rainfall for Seattle. Okay, what is Seattle? Seattle location is, as you can see, is index number 3, right? Row number 3. And there are a couple of ways I can do this. So once I extract the row number 3, I can either use column number 0, 1, 2, right? Or you can say rainfall as well. So usually I prefer this when you guys do this because, right, rather than saying, actually let me do this. Rather than saying like this, something like this, right? You can do the column number 2 because this is kind of all mysterious, right? So I would rather, if you guys have the column name, use the column name. So anyways, who's reading your code, will say, oh yeah, I'm getting to select the rainfall attribute. That's it. Right? Okay. Data frame manipulations. So right, how do you set the data? So here, right, I'm setting the rainfall to San Francisco 12. So what is it right now? It's San Francisco rainfall is like 10.2, I think, right? I'm setting this to 12. Oh, sorry, so population, I'm sorry, right? So population 12. So very simple, right? Just do the indexing. So row number 1, okay, column number 1. Remember, everything starts at 0, right? So 0, 1, setting it to 12. That's it. Adding more rows. So let's say I want to add San Diego to the data frame. Very simple. So what we usually do is we can create a new data frame. Again, this is just one approach, right? San Diego. So you can see the same thing, right? I'm expecting a new data frame. Again, look at the format, right? Key, value, column name, column values, column name, column values. That's it. So that's my new data frame. And I'm simply saying, cities append San Diego. So you can imagine, right? So kind of like this, right? So I have a new data frame, say for and D. So this is my new data frame. I'm simply appending at the end. That's it. Print this out. There you go. San Diego shows up. All right. And if you look at the index, I need to sort of do some change about the index because it's in the original index. I need to sort of set the index to. Let me put a to-do item here to modify the index. Okay. I'll update this one. Yeah. And finally, guys, and this is what's going to, we are going to be using quite a bit in our machine learning, searching. So let's say I have a data frame. A lot of the time you're going to be doing searching, and this is what, this week you're going to do quite a bit when you do data analytics. For example, I say, okay, find me all the cities where the population is greater than 10. Okay. So here's the location, right? So basically, here's the syntax. So first, I'll like you to come up with the filter. This is called a filter, right? So this is a condition. So what's my condition? Cities, population greater than 10, right? Now, if you can imagine, right? If I just did this, for example, let me do this real quick. All right. Okay, I'll just simply say, right. I think I do like a, yeah, right? So this is San Francisco. So what I'm doing here is I'm actually creating a filter. I'm not doing like I'm not hard coding the index here. I'm actually creating a filter. I'm saying, okay, what's my filter? This filter has to match everything, right? So let me execute this. We'll see what I mean by this. See, this is a trick. So when I do this filter, what am I getting? I'm getting a Boolean data frame, true, false, true, false, true, false. And when I plug this in as an index, you can imagine what's going to happen. Only the true are kept. Everything else is filtered out. Does that make sense, guys? Right? So this is like a, and this, trust me, if you need to master one thing from this in this notebook, this is it. Filtering, right? Or searching out. Yeah.
So what does that cities refer to? Because I see a column header city. But...
Oh, the cities is actually a data frame. So this is actually a data frame. Yeah.
Gotcha.
So, yeah, this guy, the whole thing, right? Exactly. Yep. So, all right.
Is there any way not to provide that? Like, I feel like a data frame. Again, we are referring to data frame, column, then filtering. So, is there any way without giving cities population? Is there any other way we can able to query something like a simple sort of thing, right? The cities dot query greater than 10, some population.
Yeah, actually there is. Again, I'm not sure the syntax. Don't quote me on this one. It should be something like this, right? So, can I play around with this one? You can do something like cities, filter, and then you can do something like. Again, this probably won't work. That's why I'm putting in the comments. Okay. Something like this, all right? So there's a function called filter. You can try this out, right? So this will give you like a very simple right? You can say population greater than 10, right? So this way it's almost like running like an English language filter. Right? Okay. So try this out again. Don't quote me on the syntax here. It'll be you maybe massage the syntax a little bit. Let me actually try. Let me brave this and try if this works.
Yeah, sure. Yeah, this is helpful. And one more question.
Yeah, right. There we go. Yeah. So yeah. Anyway, so you need to kind of figure out the exact syntax. Yeah. Yeah.
Another question, like a single quote versus double quote. I keep seeing people refer single quote to double quotes. So what is the recommendation?
In Python, doesn't matter. I know if you're coming from Java world, right? In Java world, we were kind of strings, right? We are used to thing. So Java strings go like this, right? Actually, not code, right? So Java strings are always double quotes, right? In Java, strings are like, the characters are single quote. But in Python, they are the same, right? So single quote, double quote doesn't matter. Personal preference, whatever you guys, works for you guys, right? Yeah. So yeah, there's no, yeah, I know coming from a Java world, I know the difference, but in Python, it's the same. Yeah. Yeah.
Thank you.
Good, guys, right? So here's the kind of, right, again, you don't have to go and spend hours kind of looking at this. What I always recommend is as you're doing exercises, kind of, focus on something like this. Like, how do you do these expressions? And this will save you quite a bit of time later on, right? So, right? So these are called, again, I call them filters, and I know there's a name for this. This expression can be as large as you want. For example, you can say, you can do things like, population times 1.5 greater than 10. I don't know, right? I don't know if that makes sense, but you just get the idea, right? so you can pretty much do any Python expression here. So, all right, guys. So this is the main takeaway here. Okay. And here's the, again, you can sort of see I'm building on this one. I'm saying, okay, filter out cities where the population is 10 and the rainfall is less than 10, right? So again, so what are we doing? So we already got the one rule figured out. So all you gotta do is just put an and to it, right? So here's my first rule: population greater than 10. Next rule: rainfall less than 10, right? Combine them together, it's just like an if condition, right? Combine them together, and if you do this, right? Again, let's try this real quick. All right. And this is why notebooks are really great for you to experiment. So if you're not clear, you can quickly say, all right, let me do another code sample here. All right. I think that should work. Did I miss this one? Oh, yeah, sorry. Yeah. You're gonna get a true, false, true, false. I'm sorry. Okay, yeah, sorry. Okay, okay, yeah. Sometimes these things. There you go. All right. This is the magic. Right? When you do the filtering, you're going to get a true, false, like this is called Boolean array, right? And what we do is when we give the index as a Boolean array, only the true, whatever rows match the true are kept. Make sense, guys? Yeah, that's it. So kind of, pay attention to this one, especially, right? I'll kind of delete this. I'm going to clean this up a little bit, right? So CSV files, reading CSV files. So this is the most important thing also, because this is what you're going to be doing most of the machine learning environment, right? So very straightforward. Pandas.read.csv. You can give the CSV file either URL or a file name. Either one is fine, right? Read it straight up, and then it's going to give you the data. And by the way, if you're looking at this, I'm just one of the trick I'm using. I'm not doing this, right? I'm not doing print house sales. Watch what happens, right? If I do print house sales, I'm using the Python print. So that gives me like a little string representation, like just a text representation. It's okay, but it's not very nice to look at. So usually what I do is when I print data frames, I just give the data frame name as the last line in a cell. So what it tells the Jupyter Notebook is basically, execute the expression, which is the data frame, and print the data frame. And that's a much nicer output. You can see, right? Right, you sort of see, columns, you can see, row highlights, right? So if you need to print out data frame, you can definitely do print, but this is much nicer output. All right.
So one question, when we load file to a data frame, does Pandas will provide right column type, or we need to set that column type?
Great question. They will try to do the column type automatically, right? So let me see if I can do this. So yeah, let me see if I can do this. They will do the right thing for you. They'll try to guess the column type. So is it house sales? It's info, I believe. There you go, right? So if you do house sales info, or actually I should say D types. Oh, okay, there you go, right? So if you do house sales D types, it'll basically tell you what each column it figured out, right? So it says sales price, it says that it's an integer, right? Bedrooms integer, bathroom floating. Maybe I'm sure there's a bathroom, like, you can see things like, there we go, 3.5 bathroom, 2.5 bathroom, right? So it's assigning as floating point. Like for example, date, it didn't really kind of get it because, maybe I'm guessing the reason is because some of the dates are in sort of, not in the right format. So it says it's an object, right? Yeah, so D types is what you want to find the types, right? So that's a good one, yeah. So
if we load from a Excel file, so do we need to format the Excel file to right type before loading to data frame?
Actually, Pandas has a read Excel function also. But usually what we do is, right? So let me show you the API here, right? And see, read Excel.
Yeah.
Right. So you can actually read Excel file directly, but usually what we do is we export the Excel spreadsheet as a CSV file first, because then everything is text, and then read that. But if you have an Excel file, you can read this too. Again, you sort of read the doc to see see what Excel version they support and all that. But yeah, usually I stick with CSV because CSV file you can load in Excel anyway, right? The Excel can read CSV files easily. So yeah. Okay. And if you look at the read CSV, you can see all the options you can take. So it's pretty extensive. Right? I'm just giving like one option, right? File path. That's it. Right? Everything else, there's so much you can customize. Right? So let me see if there's one more type I want to see. this is a good. Let's see if it was an object. Oh, there we go. The info is what I want. There we go. All right. Not info, information. So this is pretty neat. So when you, as soon as you read a data frame, I would recommend you guys actually do an info, right? So you'll kind of give like a column-based stats, right? What's the column name? You know, what's the type of the column, right? And is there any null values, right? So it's to see like a non-null null, right? So it says this column, you know, sale price has 100 values, right? Not null, right? So, right. So this is pretty cool. So you can sort of use the info, and also it will give you like, you know, how much memory is taking the memory and all this stuff. So anyway, so look at the info function is right, pretty. Yeah, definitely. All right, guys. Any questions on the reading data side of things? Trust me, this is what you're going to be using, I would say, majority of the time. Pandas read CSV, right? So it kind of helps to kind of, you know, if you go to the CSV, you know, function, you can see, right? You can sort of look at some of the options. You can either do like a header. There's a header here, right? There's like, you know, you can even give the names if you want. Like, for example, you want to read this. So here, Pandas is actually figuring out the header from the you know, right, from the row names from the header, right? The CSV files have header info, so it's doing the right thing. But if you want to change any of these, you can specify these as well if you like. Yeah. Good, guys. All right. What else we should do here, guys? Okay. So, and finally, I read the data frame. I want to do some basic analysis. So I ask you guys, okay, how many sales per bed, you know, for 4-bedroom houses, right? So there are multiple ways you can do this, right? You can, you know, extract all the 4-bedroom data. Now you guys know how to, right? You can do like a filter, right? You know, right? So again, this way, this is important because, you know, these things kind of keep building on each other, right? You can say, okay, you can say house sales, bedrooms greater than, you know, equal to 4. So that's going to give you all the 4-bedroom houses, and you simply count how many records do you have, right? So you can sort of do that. Like, for example, right? You can do things like, right, house sales, right? You can say log. You can say house sales, bedrooms equal to 4, right? And you can say 4-bedroom, right? Then they should work, right? And then you can simply say how many how many 4-bedrooms we have. You simply say size. So we have 352, right? Data points, right? Also size gives you, okay, sorry, no, len, right? 32, right? So what it means is like, so the way you read the shape is like rows and columns. So you just say 4-bedroom has, you know, 32 rows and 11 columns. Why? Because the columns doesn't change, right? How many number of columns you have. Oh, you can do like this too. Like you can do like a group by and size. All right. So multiple ways of doing this. So when you do group by bedrooms and do a size, it kind of gives you like, you know, everything, right? How many bedrooms and how many, right? How many sold.
So just a general question. So I'm coming from the SQL side of the world, and I see a lot of patterns to, you know, that.
That's right.
So it's pretty interesting.
Yep.
So do we also have like a standard other stuff we do, like aggregation functions or?
Yep, absolutely, right?
You know,
Yeah,
count distinct and, you know, those type of things.
Yep. Yeah. So we go to Pandas API. So let me see if I have max. All right. So, you know, this is a read function. So if we go to aggregation, usually when I switch, okay. So when you do the max, there we go, right? So
yeah,
you can
got
see,
it, okay.
right? Yeah. So you go here, and then you can pretty much, you know, find, you know, all the usual things, aggregate. Anyway, yeah, all your SQL stuff is basically here, right? Yeah. So yeah, and this is why Pandas is great, because actually it's intentionally written to basically, you know, appeal to people who come from SQL, right? Because in SQL we are so used to saying, you know, group by distinct or group by match. You know what I mean? We can do so many things together. So Pandas has a lot of the APIs to match those two. And usually, you know, when you see like in Pandas, when you see the API, like you instinctively know, yeah, I know what this means. You know what I mean, right? There's no explanation needed. Yeah, because they try to mirror the SQL. Yeah.
Thanks.
Very good, guys. So that's a notebook. Again, if you're wondering where the link is, it's all here, right? In the, so it's either in the classroom, right? I put the links here. Excuse me. Also, in the session session outline, you can find the link as well, right? So I can, so I can sort of putting it here because this way, if you're reading this, everything's in one place, all right? So, good, guys.
Going back on loading data, for example, from CSV, if we have different sizes of, say, lines, then we might get something like null values where the others do not have.
Oh, you mean how do you deal with null values?
Yeah, for example, look, somebody tries to load the CSV file, but it's really a mess. It is mixing, I could say, longer lines with smaller lines of data. Some values are missing, for example, and some others you think they're all numbers, and then you have a string. So I suspect you may have null values, you know, and actually, when there is a mix of data, I think it's going to go to the common denominator as a string.
That's right. So yeah, so and this is what we are going to be looking at this week, right? And I'm going to give you some materials to read and do some exercises. Yeah. So a short answer is, Pandas tries very hard not to error out, right? So if you have like a really messed up data, let's say some columns are missing, or some columns are wrong data type. Like for example, let's say you're expecting an integer. Let's say, let me just do this. Let's say you're expecting an integer for sale price, but let's say you're in one of the columns has ABC or something, right? So Pandas will look at that and basically say, okay, you know what? I see a non-integer value, so I'm just to be safe, I'm going to treat this as an object, right? Object is basically string, right? Now it could be any object, but usually string. So Pandas will basically do the upcasting for you just to be safe, right? And let's say you're looking at something and there are non-values. Basically, that's going to be null values, right? Pandas say, okay, I'm expecting something here. I don't see anything, so I'm just going to put null and move on. So very rarely, Pandas will error out because of bad data. It is explicitly designed to keep going.
Yeah, so from what you say, I think a red flag for somebody to manipulate data is actually to find an object column.
Yes. So and then and this is what this week you guys are going to do. And once you read the data frame, right? When you do things like info, let me show you guys one more thing. And this you guys will do in the next lab today. But I just want to show you guys describe, right? So the Pandas has its functions, right? So in one quick look, let's get this. Give me one moment, please, because the output is kind of messed up. All right. I can never have this straight, so I would like. By the way, this is something I'm showing it to you guys. So this is something I do, right? And I recommend you guys do. So what I do is I have a Git repo, like on my private repo, where I collect code samples. Right? So this is me, right? So like for example, you can see, right? So let's say Python, right? And for Python, I have like a thing called say, whenever I find something useful, I sort of save it. So Pandas code sample, right? I'm going to show you this guys, for example, right? So like small stuff, for example, I want to lowercase everything in the data frame. Again, it may take you like 5 minutes of researching, right, googling around. But once I find a solution, I just keep it here. So this way, next time I just know I need to come here, right? So I'm going to show you guys something come in handy. So there you go, right? This is how to display numbers. This is how we format the numbers. So this is something I spent quite some time researching. Now, when I want to have this, right? See, now the numbers are nicely formatted. It's no longer doing the scientific notation, right? So we need to describe command. So describe command, one thing it will tell you is the count. So each column is going to give you a count. And in the count, it will basically tell you if there are null values. Right? So right now this data frame has 100 rows. Looking at this, you can see all the columns have 100 rows, 100 rows, meaning there's no null values. So you don't have to look at the data frame manually. You can do like this high-level function like describe and info to give you an idea of how your data looks like. Because if you have like a million rows of data, you cannot manually inspect them all, right? So you need like a summary basically, right? So if you're coming from our world, this is like a summary. So it goes through okay, how many rows, how many non-null values I have, right? And also it's going to give out like things like what's the minimum value, what's the maximum value, and all that. Does that make sense, guys? Right? So yeah, so Pandas has some pretty good summary functions that you can use to kind of understand your data. Right?
Is there any way to get the maximum nulls in a given column something? So if we have, for example, we are having 100 nulls. So is there any way I can able to understand, okay, sales price having 20, like a
Yes.
property ID?
Absolutely, yeah, right? So for example, right, so let's say the sale price had 2 null values, it'll be like 98, right? It'll sort of subtract that up, see what I mean, right? So my data frame has 100 rows. Let's say sale price column had 2 nulls. Okay. So, your count will be 98. Does that make sense?
Yeah.
Yeah, exactly. So that's why this stats column-based stat. You see that? Yeah. So I'm a big fan of the describe function because it takes a little getting used to kind of read this, but it prints out lots of useful information. Again, this is what, again, I don't want to sort of jump the gun here because this is what you guys are going to do in this week, right? Analyzing data. But kind of, right? I'm going to just giving you some, some heads up. Yeah. So short answer, you're asking the great question, and this is what you guys are going to do, like dealing with kind of messy data. And Pandas, trust me, Pandas has everything built in. It's just for, just a matter of us using it. Okay. All right, guys, so let me delete this because it's next week. I don't want to mess up the notebooks. All right, so notebooks are here, right? All right, guys, and if you look at this, if you look at the original, my questions and Panda, right? So I haven't given, like I have given you a bunch of things. I know in my solution file may not have everything, and what I'm looking for is I'm looking for some help for you guys. If you guys can, if you guys have any solutions ready to go, please let me know. I'm happy to sort of take your solution and put it here, right? Because I want to sort of, I only sort of did this just to sort of highlighting some of the important sections, right? So some of them missing, so I'm always looking for some help. So if you think if you have a complete notebook, just email me the notebook, and I'm happy to sort of put your name, and also I'll put your if you like, I'll put your name here to ask for credit, right? So you guys are helping me create this. So good, guys, that's Pandas. All right. Any other questions, guys, on this one? So again, you got a notebook ready. Let me show you the next one, visualization solution.
I don't know if you have read the question I had.
Oh, sorry, I haven't looked at the chat window yet. Give me one second. Yeah. What is the question?
I see that we might run into trouble of running out of memory if we have really big data sets.
Right.
So
yeah.
Would be nice if there is I would say a ready-made solution, or we have to devise a solution to run our processes into batches. I don't know.
You can. So when you do read CSV, you can do like again. I need to look at the API, but you can specify a max number of rows to read. Yeah. So somewhere here we can do like a max, right? There should be a way you can limit n lines or something. Anyway, there's a limit you can apply, right? So please take a look at this one. Yeah. So read CSV, but usually, right? And this is something you have to keep in mind. Pandas is designed to be a single machine system, right? Meaning all your data has to fit in one machine, right? So that's why the info column is great. When you look at the info, right, you see this, right? It tells you how much memory it's using, right, in memory. So yeah, so this should give you like a little sense. For example, you can say, okay, if I'm reading 100 rows, that's going to take up 8 kilobytes memory, right? You can sort of extrapolate it a little bit, right? So yeah, Pandas will tell you the details. But otherwise, yeah, sometimes if you have a lot of data, Pandas and pretty much all the Python libraries are written using an assumption your data fits into memory. There's another library that's I heard about. I'm not sure if I have a I don't remember the name. Is it Norton? I think so, maybe. All right, let me see. I think this is the one. Yeah. Okay, so what the guys are doing is like these guys are basically doing like a highly efficient pandas. Using like for example they have their own engine to process. So take a look at this. I'll just put this link here for you guys. I'm not going to spend too much time. So take a look at this one. They're basically doing the same. They're trying to make pandas more efficient and more memory, more faster and more memory efficient. Right. So take a look at this one. So they're saying this is like almost like a drop-in replacement for your pandas. Okay. So take a look. Yeah. So that is true. If we have lots of data, right? Let's say, because remember if you look at like a little little diagram, right? So imagine this is your machine, and let's say you have like 10 gig memory, right? And that's pretty much the the data. So all the pandas and all the pandas, the Python libraries are written for single machine systems. But what do you do if you have like 1 terabyte of data? Then you have to go to something like Spark, right? So Spark is basically a distributed platform, right? What it'll do is basically, it's going to run on a cluster, right? And your data is going to be distributed across many, many machines, right? What Spark will do, right? It'll distribute your data across many machines. And I'm curious, has anybody worked on Spark or Hadoop here? I'm curious, right? So this is where your big data platforms come into play, right? So I just did a class on machine learning with Spark just last week, and the reason the company, I had in my class I had data scientists who were using Python and Pandas, right? So what's happening for them is they are basically their data set is growing. They're kind of in hundreds of gigs right now, and they're expecting their data to be in a few terabytes by next year. So obviously, right, they're kind of approaching the limits of Pandas and Python, whatever they can do single machine. So what we are teaching them is how to migrate the algorithms from plain Python Pandas into Spark. Right. So
this has to be like a all-inclusive physical storage, right? It's not like container type of storage. It's a physical storage.
Memory, yeah. So it's specifically memory, I believe. Yeah, basically, yeah. Is that what you're asking?
Right. So it's not. These are not container-based. These are like physical device-based memories.
Right. You mean like yeah. So yeah, these are like the.
I'm talking about when he first started questioning, I was thinking about options in Amazon like auto balancing. I was then, like you mentioned, it's a single machine system, so
yeah,
it obviously needs a dedicated machine for that.
Yep. So we are starting with sort of Pandas and Python and Scikit. Because remember, a lot of the machine learning still run on single machines, right? But eventually, if your data is exceeding a single machine capacity, either you have too much data, you just put them in the memory, or it just takes too long to compute. And one of the things they said was they have a workstation with 150 gig, 256 gig memory to run analytics. This company, right? I was teaching them last week. So, but they said when they run this query, it takes them about 3 or 4 hours. So then, I show them in a Spark cluster, just using a 5-node Spark cluster, the same query, they can run it in about 20 minutes, right? Because why? Because Spark distributes the data. Not only that, it also distributes your compute, right? Kind of the way you have to imagine this like this, right? Your compute system is distributed, right? So when Spark runs a query, it's going to be running this on many, many machines. Does that make sense, guys? Right? So that's how Spark actually scales.
So Suji, I have a question.
Sure.
In an organization that's their data is growing, they don't know, they really don't know how much data they're going to be working with over time. Why wouldn't they a company start with
Spark right away.
Spark right away and big data
Yeah.
and why would they even bother going to storage in a cloud or even storage on-prem or something like that?
Yeah, that's a very good question. It's a bit of a growing, so when you want to use Spark, right, there are two options for you. Either you need to have Spark cluster in-house, right? So that means as easy as Spark is to use, you still need to have somebody kind of, installing and managing and babysitting the cluster, right? And so this is like a, could be an IT team or a DevOps team. So if you don't want to do it in-house, you're doing it do it in the cloud. So you're going to Google Cloud, Amazon Cloud, you're spinning up a Spark cluster and doing your work. So there's a bit of an infrastructure you need to have to make this happen, right? So, but as opposed to like, just a simple Python Pandas based system, anybody could, set up on their laptops easily and get going in like 5 minutes, right?
Excuse me, what?
And if you don't have the data to justify it, and again, so, right, again, this is where, kind of, you have to kind of make your decision, right? So for example, imagine you're kind of doing like, like you kind of said, you kind of doing like a data plot, and you're kind of saying, hey, my data is kind of, going like this, and pretty soon I'm going to be like, above a single machine capacity. And I know that's maybe in 3 months, 6 months, 2 years, whatever. So you kind of have to plan ahead and say, okay, so now we are fine using like workstations with some with some memory to do a Pandas or Python, but this is going to help us. This is going to scale in 6 months, right? So this is called capacity planning, and this is something you have to sort of work with your team and sort of look at your data and figure out where you want to be. If you expect your data to keep growing, I would recommend you guys start with Spark right away, because this way your system is kind of future proof. But also, having said this, there's a bit of a how do you say, the bar's a little high to kind of get started Spark, right? Because you have a cluster and everything to kind of to ready to go. But with the cloud vendors now it's easier, because you can just spin up a Spark cluster in 2 minutes and do your work, right? So.
Excuse me, may I ask a question?
Please go ahead. Yeah.
Yes, thank you. So with what you explained about a Spark, is also something that some services like Amazon provided, like pipeline?
That's right. Yeah. So if you go to Amazon, yeah. So like we go to like Amazon, you can say, let's do a search for like Spark on AWS, right? So in Amazon, they call it something called EMR, right? So what they do is, what they're kind of giving you is an on-demand cluster. So you can spin up a cluster in like, basically, in a couple of minutes, run your application, and then shut it down. So because since Spark is very popular, pretty much all the cloud vendors support Spark.
So what's the difference between this and pipeline?
Because when you do pipeline, Amazon pipeline, you are basically logged into Amazon ecosystem, right? So because and this is what again decision you guys have to make, and this is what we call cloud native. So when you're using Amazon's native pipeline, for example, like you can say Amazon Lambda, right? AWS Lambda, right? This is basically a serverless compute engine Amazon provides, right? However, when you write using this is it, right? You're basically logged into the Amazon ecosystem. So let's say now you're moving to Google Cloud. This you have to basically rewrite whatever you wrote in the Amazon Lambda into whatever the Google API is. But let's say you wrote using Spark, right? Spark on Google Cloud, right? Google Cloud has, they support Spark. They have a different name called Dataproc, but it's basically Spark. So the way you have to think about this is like this, right? When you're doing a new system, and then this is a kind of a bigger topic than data science, right? I kind of look at this like this. Here I look at all your cloud vendors, right? So this is AWS, Google Cloud, and say Microsoft, right? You can actually write native code using the API. So let's say this is AWS, GCP. Sorry guys, I'm gonna mute you guys. There's a lot of echo on the line, but if you need to speak up, please unmute and speak, right? So let's say this as your. So when you write your code right here, right? When you write your code on top of AWS, that's pretty much your vendor lock-in. That's it. You're basically logged into whatever AWS APIs are. But what Spark gives you is another layer of abstraction, right? So when you write on Spark, your code is basically dependent only on Spark, right? And that is transportable to any cloud environment you want. And for some of our clients, this is very important because they don't want cloud vendor lock-in, right? Because, for example, like let's say now they have a deal with AWS, and let's say next year Google gave them a really good deal, and then they want to move to Google very easily. So if you did this, now it's pretty much a complete rewrite of all your environment from AWS to Google. But if this is what you have, you can simply run your Spark code any way you like, right? With minimal prep. Is that going to make sense? So what's your dependency level, right? I mean, so obviously cloud vendors, they want you guys to do this, right? Because they want you guys to kind of use their native APIs so they can lock you into the ecosystem, and then you never leave, basically, right? Because leaving from one cloud to another cloud is pretty much it's a lot of work. Very few people do it. But some companies, this is not acceptable. They want to have the freedom, right, to kind of move to any cloud environment they want. Right. So for example, like Walmart is one of our clients, and they are very big on Spark. The reason is even though they are basically going to Google, right? Obviously, you can imagine Walmart is not going to go to AWS, right? So, for obvious reasons. So they use Google Cloud and Azure Cloud, but still they are maintaining the independence by using Spark. And also there's another thing I'll just throw in here. It's called Kubernetes. I don't know if you've heard of this one. It's like a compute engine. Sorry, not compute engine, a cluster engine that you can use to manage your infrastructure, right? So that also will give you little freedom. Anyway, so this is kind of more towards like your architecture and everything else, but I hope this gave you some idea.
Excuse me, so containers or Docker files that we hear also, they are kind of Kubernetes?
Yeah, Kubernetes, yeah. So when you're doing it, so here I would just say Docker and Kubernetes here, exactly, yeah. So that's it. So when you have, so for example, if you standardize everything in Docker, then yeah, you can pretty much deploy Docker and Kubernetes in any of the cloud environments, right? So you're kind of, protecting yourself and giving yourself choices down the line, basically, right? So. Cool, guys, right? Very good questions. And this is why I like to do these hours, because like I said, everybody kind of learns from all the questions, right? All right, guys, let me quickly run through the next solution, which is basically visualizations, right?
So
again, sorry, question?
Yeah, one question. So let's assume if the data is within the limits 10G, so like SQL, is there any option we can able to fine tune to improve the performance?
On Python, you mean? I mean, on Pandas?
Yeah.
Yes, yeah. So if you're using Pandas, there are some projects underway. Like you can definitely check out Modin, because that's exactly what they're trying to do, right? They're trying to make Pandas more efficient by doing a new execution engine and also a new memory layout engine. So again, I haven't used them personally, so I don't know the details, but you can definitely check these guys out. But yeah, there are libraries on the way that will kind of help you optimize your code on a single machine. Yeah. Okay. But just to kind of on the same thing. I mean, Pandas is very very fast, right? If you remember, the way Pandas works is it uses NumPy, right? So right, if you remember sort of the Pandas, right? At the very bottom is Pandas NumPy, right? And then NumPy is basically native code, right? So NumPy, even though it gives you a Python API, most of the NumPy is actually, right, is in C++ or C, I believe, or either one. Anyway, so native code, right? So even when you're using Pandas expressions, Pandas actually using NumPy engine to execute. So it's, it's plenty fast.
Yeah. Okay.
Yeah. All right, guys. So question was UDF. So this is like user-defined function, I believe. Is that right? So in Pandas, you can write UDF.
Correct. Yeah.
Is that the question? Yeah?
Yes. Yeah.
Yeah. So how are you using UDF right now? Is it for like a part of a SQL query or something? Can you tell me a little bit more?
Yeah. So the UDFs I'm trying to develop for data wrangling.
Gotcha.
After I build my data frame, after that I want to run through the UDF so I can optimize the code for parallelization and distribution.
Got it. Okay, so I'm going to give you a little conflicting advice here. Here's why. Let me think about this. So let's say you're doing a lot of custom processing, right? There are two ways you can do this. One, you can write your custom processing using the standard Pandas API, right? So you can do like, Pandas, function 1, right? Pandas function 2. So your actual function, let's say you wrote your own function, right? Okay, sorry, I can't make a mess here, right? So let's say your function is, let's say, right, my func, right? That takes a data frame, and then you are doing some custom work, whatever that is, right? And let's say you're doing some data frames, you are calling some, X, data frame Y, something like this, right? Versus, let's say next approach is, you're sort of doing you're sort of having like a custom function like that for UDF, and you're kind of doing like something like data frame, I'm just exec UDF, something like this. You're kind of giving your own function to execute, right? Now, from my experience, I would recommend you do this because when you're using standard Pandas APIs, they know how to optimize your code very well. As opposed to when you give like some random UDF that you wrote, right? It's going to run this as is because it doesn't know how to read your code and then optimize your code. See what I'm saying, right? So a lot of the runtime compilers, like for example, if you use the Pandas function, say max, I'm just making this up, right? If you use the Pandas function max, they will know what's the best way to run max given your data frame. But if you're kind of finding max on your own custom code, it will just run your code as is because it doesn't really understand user code, and so it won't do any much optimization. So unless you can beat the optimizer, which is possible but very hard to do, I will just stick to using standard Pandas functions. Is that going to make sense? But sometimes you really have to do UDFs. I mean, I understand that because sometimes you're doing some very complex calculations, operation. There's no way to do standard. So in this case, so be it, right? So I'm not saying don't do this. I'm kind of saying, try to do this as much as possible, and only do this as a last resort. Is that going to make sense, right? So same like in SQL, like when you write a SQL query. So like, for example, if I wrote a SQL query like, select star, right? Where, some condition, SQL compilers will know how to optimize this condition, right? I can say, it's where X greater than 100, right? So they know how to effectively execute this. But if I gave my own UDF in SQL to execute, most optimizers cannot optimize user code, right? And they will just execute it as is. So anyway, so short answer is, I'm not saying don't do it, but I'm saying, kind of keep this in mind and try to use standard APIs as much as possible. But if you write your own, so be it. Yeah. Okay. Yeah. Hopefully that gave you some answer. Gave you an answer. Yeah. Good, guys. Any other questions on this one?
Thank you.
Yeah. Very good, guys. Let's see. All right. So very quickly, right? So again, I'm trying to limit these sessions for like a maximum hour and a half, right? Because I know people are in different time zones and we don't want to take too much time. So let me quickly zip through the visualization solution, right? Again, you guys have the links for all of them, right? Here and also in your welcome guide, right? If you look at today's notes, my solutions are here, right? And also what I would do is I'm going to open up your submissions as well, so you can look at other people's submissions as well, right? So this way we can all learn from each other. All right. Again, visualizing, we're not going to get up, we're not going to go too deep into them. I just want to do some basic plots, right? You will see this code. Basically, what it's saying is like, whenever you do visualization, just display in line, right? So let me clear all the outputs so we can start from scratch. So here's my data. I have like 2 arrays, right? Imagine I have just 2 data points, and I'm trying to understand, is there any relation here between these 2 guys? So the simplest plot is scatter plot, right? Just put in X and Y. So, X-axis and Y-axis. So this is X, this is Y. And you will then say, okay, yeah, looks like, there's some, some relationship, right? When this guy goes up, the other guy is also going up, okay? And if you want to add titles and things, you can sort of, pretty it up a little bit. Right, there we go, right? You can put a title here. That's it. So again, we just want to do some basic plots, guys, right? And if you look at, I'll put this link in the link, matplotlib. If you want to get really get into this, there's a book, right? Matplotlib, master matplotlib, yeah. All right. So anyway, right? So there are actually books written for this subjects. So we just want to get some basic idea. All right. So that's basically a scatter plot, X and Y, right? Just to get a quick idea of the data. Then let's say you have a bunch of numbers. Let's say this could be house sales numbers, what have you, right? And you want to understand the numbers. So the simple thing to do is box plot, right? Let me show you guys how this does, right? Again, you can see these are like one-liners, right? So what is PLT? Plot is the matplot library. See how I'm importing this, right? So there are two libraries, matplot and seaborn. Matplot is sort of the workhorse of Python. It produces decent graphs. Seaborn graphs tend to be a little prettier, right? So that's why we have seaborn engine as well. So I'm showing you guys both options. You can stick to whichever one works for you, because it's more of a personal choice. I'll show you guys both. So here's boxplot from matplot, right? Plot.boxplot, just one liner. Same thing using seaborn, you will see, right? I don't know, a little nicer maybe. So, but the same graph, right? Boxplot. So what boxplot says, it says what's the minimum, what's the maximum, right? And also this is basically, the percentile. Like this is like 25th percentile, this is 50th percentile, 70th percentile, right? And we'll sort of look at these a little, little in depth this week when you do stats and analytics, right? But just for now, so looking at this thing right away, I can say, okay, I can sort of see this is kind of between like whatever 22 or something, and then maybe 70, right? And right, so imagine you have a million numbers. Looking at a box plot will give you a pretty good idea of how the numbers are laid out. Right? That's it. Same plot, just a different stylus, right? All right. Line plot. So line plot is basically, let's say just some data frame. You can sort of see here, right? Print data. Okay. All right. Let me actually do this in another way. How they make this so difficult. All right. One moment, guys. All right, so let me execute this here. I want you to see the data. So just imagine some sales number or whatever, right? Doesn't matter. So this is matplot. And just line plot. And this is seaborn, right? Same data. Seaborn has a pretty standard format. You can sort of see here, basically X, Y, and the data, right? So there we go, right? So not much difference here. So here's a bar plot. So let me another one just to make this easier. So here's my data, right? And
do you have any three-dimensional examples or more than 2 dimensions?
I don't have one here, but what I'm gonna recommend to you guys is this one here. If you guys go to the link, the Python graph library, right? Graph gallery, actually, I should say. This one has everything you can ask for, right? Look at the Python graph gallery here, and they'll give you like, and no, you can choose, right? You can say, what kind of a graph you want. And also you can choose, I want seaborn, I want matplot, right? And then they will give you all the charts type you can imagine, right? Let's say I want to do like, something like this. So click on this, and then they will give you the sample code as well, right? See, so this is a go-to place, Python graph gallery, right? Yeah. So the link is right here in your guide. A link is there, right?
Okay, thanks.
Yeah. So here's the here's a bar plot from here's, you can see, right? Here's like a the matplot one and the seaborn one, like a nice pretty colors and everything, right? So again, like I said, seaborn graphs tend to be a little prettier out of the box, and that's exactly why seaborn is created, right? Their fonts are a little nicer, the colors anyway, right? So they're gonna try to do a nicer graph out of the box. Either one is fine, guys. Again, like I said, this is not a visualizing course, right? We are going to use graphs as a way to understand the data. So whichever one works for you guys, stick to it, right? So, and here's a pie chart right here, right? So you can say, here's my data. So usually when I do this, you'll notice this, I cannot put the data in a separate code block, just so I can sort of see the data, right? And then I can get the plot, right? Again, once you guys know this, I'm giving you guys this as more like a, how do you say, a reference code. So let's say you want to do like a pie plot, just copy paste the code, right? Right. So that's use it as a reference code, guys. That's it. Okay. Here's a histogram. Okay. Histogram is basically, right, the way to read the histogram is, let's say you have some numbers, right? The numbers are, right? So the way I said, do 5 bins. So you divide the data into 5 bins, 1, 2, 3, 4, 5, right? So you divide the range into 5 bins and basically do like, for example, 20 to 30, for example. How many items do you have, right? 3. And, 30 to 40, right? Whatever, right? 2 items. So for example, let's say you're doing some things like analyzing people's salary, like how much salary people are making between 20 to 30,000, 30 to 40,000, right? You're kind of counting. That's it, right? And same thing in Seaborn, right? So not only that, it also gives you like a nice bell curve, kind of, so you should see, right? Does it fit into my bell curve as well, right? Like I said, Seaborn tries to do a little, something a little extra. So, all right, guys, again, just some sample code, okay? You can feel free to play around with this. Use this as starting point, right? Okay, so now I'm going to put kind of everything together. We want to sort of visualize the house sales. So let's read the house sales data, right? From the same data you guys been using. So I want to say how many sales per bedroom, right? So we did this. This is interesting. So I group by bedrooms, and right, and you can see, right, 2 bedrooms, 3 bedrooms are the most popular one, right? 12,000 sales. Interesting. See, there's a 33 bedroom house. Interesting, right? There's only one of those. There's a 13 bedroom house. Interesting. So when you guys do this basic analysis, and we are going to do this more of this week, right? You'll sort of say, oh, interesting. There are some outliers, right? Because how many, right? How many people have a 33 bedroom house, right? By the way, this is real world data. So if you look at this data, let me see where the zip code is. Let me see where this one. Right, there's a zip code. Right. Where is this? Of course, yeah. This is Medina, right? So this is this is Seattle, Washington D.C. So you can see right on the waterfront. So I believe around here is where Bill Gates' mansion is too, right? Medina is, I think, his hometown. Anyway, so you look at the zip code, so you can believe, yes, these houses are expensive houses, right? So again, doing able to just do some basic, right? Kind of say, hey, is this price right? Is a 4-bedroom house really selling for $1 million, right? Kind of, you can sort of quickly see, right? All right, let's do some plots. All right, so here's my bedroom data, right? Sales per, So look at the Seaborn plot. Very simple, right? I'm doing a per bedroom plot count. So I'm doing a count plot. That makes sense, right? So what I'm doing is I'm counting. What am I counting? My x-axis is bedrooms, right? You can change this anything you just want. For example, let's say, let me see. Let's say you want to find the x-axis as a property type. Okay, let's try that. And this is where Seaborn is really great. So let's say I want to do like a property type count. Right. Let me do that. Same thing, but the x-axis I changed bedrooms to property type. Did I make a mistake? Not. I hope not. Okay. There you go. Right. Single family bedroom townhome, right? So very easy, right? So just doing counting. So you don't have to do like a lot of pre-calculation. You can simply give the data to Seaborn, and it'll actually do this work for you. Pretty neat, right? So again, we see the like a distribution right here, right? You can sort of see here, right? Most of the sales are 3 bedroom, 4 bedrooms, and then the longer the larger bedrooms kind of right, kind of tails off. Yeah. So when you do the plot of the data, immediately you sort of get an idea of your data, because if you just look at the data frame, just a bunch of numbers, right? It doesn't make a lot of sense. All right, guys. So right, good. Now price per bedroom. So I want to say, okay, so we have multiple bedrooms. What's the average price per bedroom? Okay, so what are we going to do? We're going to do like a box plot. Remember, because box plot is really good at giving you price per bedroom. All right, so let's do a box plot. So what am I doing? X-axis, bedrooms. y-axis sale price, and the data is coming from my data frame. Right? That's basically, so that's why you read X, Y data, right? Look at the plot. So you see the box plot, it's a little squished up, right? Why do you guys think this is all squished out? Because we have a lot of outliers. Remember the 33-bedroom house, look at the 6-bedroom house price. One of them is like sold for like a really high price. So when you try to accumulate all these values, my data is kind of squished up. Okay, so I want to kind of clean up this graph a little better. So I say, you know what? I'm only going to consider houses with less than 5 bedrooms, right? Now you can see, right? Here's my Pandas filter coming into handy, right? So I say, okay, extract all the houses. Let's say, 5-bedroom. Let me just do this. 5-bedroom, right? Actually, I'll just leave a filter. Yeah, for now. So I'm saying, okay, here's house sales data. Extract all the house sales where the bedroom property is less than 5. There you go, right? And plot the data. So the plot is a little clearer now, right? So right, it's not squished as this is, but we still have a lot of outliers. You see this here, right? There are, because there are some 5-bedrooms that are sold for really high prices, and they're kind of messing up the graph. So if you want to do this, you can say, hey, you know what? Limit this size. I'm saying, limit this. So look at the y-axis. It's going up to like 0, 1 to 6, but it's in millions, right? 1 e to the power 6. So I'm going to say, you know what? Limit your price to like just 1 million. Right? That's it. So now it's a little easier to read. You sort of see that, right? So what I do is like, I say, you know what? I don't care about the outlying prices, right? These are, these are outliers anyway, so I don't care about them. I can even read sort of the normal prices. So what I'm doing is I'm setting the y-axis limit to just 1 million. And you guys can play around with this. You can sort of do anything you guys want, right? So now the graphs are much easier to read. So you can sort of read here, right? You can say, okay, 2 bedrooms. Let's see. Remember, these are in millions, right? So you're going to multiply that by 6. 6. Right? So what is it, like 200,000, 100,000 or something around there, right? And then average price. Like look at this. This is the median price, right? The middle line. What is it, like maybe a 300,000 something, maybe 350 or something, right? So anyway, so very easy to visualize the data once you guys understand various plot types. Okay. And the final one I'm asking, is there a relation between square footage and the sale price? And we like to think so, right? We like to think like, more the square footage, the higher the sale price. All right, so let's visualize this. Let's do a scatter plot. All right. So this is the data looks like. So square footage at the x-axis, sale price at the y-axis. So you can sort of see here, right? Yeah, it's a slight increase, right? As the square footage kind of goes up, if you draw like a line in the middle, right? It's kind of going up, right? Not like this, not a steep slope, but a more like a gentle slope. It's kind of going up. Does that make sense, guys? All right. So this is how we sort of slice and dice the data and kind of trying to understand if there's any relationship. We are going to be doing a regression analysis with this house sales data, right? So I'm going to ask you guys how much impact square footage is going to have on the sale price. How will you answer this? So when you plot this data very quickly, you can quickly say yes, there's an impact, right? Because as square footage increases, sale price also slowly increases. Right? All right, guys. So that's why I sort of wanted to have all these tools in our tool belt, so we can quickly analyze the data. Again, it takes some practice, right? I know you guys just did sort of NumPy and Pandas and everything and visualizations. So the way we are building up towards is basically something like this. And this week, the assignments I'm going to give you guys, these are the things we are going to do. Right? We're going to start analyzing data, figuring out, okay, do we have outliers? Absolutely, right? So outliers, and I can immediately see, do the plot, I can say, yes, I have a 33-bedroom here, right? So these are the things you need to do before you do machine learning, because I've seen people doing machine learning on raw data, and then the machine learning algorithm don't give good results. And when we start investigating, usually what I find is like they just simply apply the raw data without doing any cleanup or any analysis. For example, if you're doing regression analysis, usually what you want to do is you want to eliminate the outliers. So you're going to say, you know what, you're only going to consider 6 or less bedrooms, because right, there's only one sample for a 33-bedroom house, and that's an outlier, right? Because that's going to mess up my model. I don't want to do that, right? Again, this decision you can only make once you start performing some basic analysis. And this is even before we pick our algorithm, right? So that kind of makes sense, guys, kind of why we are kind of building up towards this. And hopefully, I think, you can sort of start seeing the big picture, right? So, all right, guys, so that's it for this week, right? Again, solution files are here. Please feel free to grab them. And then I'll also open up the solution files. And if you have any interesting graph in your solution, please let me know, right? Because I like to put this as part of the solution file. And so everybody can see your solution and benefit from it. So please please reach out to me on Slack or just email me. Let's say you you have a cool graph you want people to learn about. Please let me know. All right, guys. So that's last week's review. Any other questions? So we have about 5 minutes.
So is this going to be predominantly used only in quantitative data?
So most of the time, yes, because the graphs, I mean, at least to me, right? Looking at numbers, my eyes kind of glaze over. But if you give me a graph, it's much easier to kind of visualize the trends, right? You know what I'm saying? Yeah. So most likely we'll use them for numbers, but also as we do machine learning later on, you will do all kinds of analysis, but dominantly numbers. You're right. Yep.
Thanks.
Yeah. Good, guys. Anything else? So let me look at the chat window here again. So I haven't been right? So this week, guys, the plan is this. Where are we going? Basic stats and data analysis, and also let me see how far we can go here. Cleanup one, right? So data cleanup. Okay, so I want to give you guys some data cleanup. Again, this can get this can get pretty extensive, but I'm going to give you guys like a couple of sample exercises so you can actually get used to some of the Python cleanup routines, right? So make sense, guys? All right, so keep an eye out for the email, and I'll send out the assignments for this week and the reading materials. Any other questions, guys?
Question on the earlier we mentioned, because like some of us we joined the class late, so we are still catching up.
Sure.
So when will be the time that we will have the week to catch up?
Oh, okay. So if I can ask you, are you catching up from the beginning? Like, are you new to Python as well?
Yes.
Okay, gotcha.
Mm-hmm.
Good question, guys. Let me do this. Why don't you send this out to the group, and you guys can tell me when to do like a break week, right? So what I'm thinking is probably like before we actually get into the machine learning, which is sort of the next week, maybe you can take a break, right? So this coming week, basically also we are doing a lot of data analysis prep work. And then maybe the week after, before we actually go into machine learning, we could take a break, because that'll be a logical break as well. Does that make sense to you guys? Yeah, that's what I'm thinking. So this way you can sort of wrap up all the prerequisites and be ready for machine learning. Yeah,
sounds good. Mm-hmm.
Yeah.
Thanks.
Thank you.
And I also I had emails from you guys saying, hey, this week is very busy week at work. I couldn't get to the exercises. I always tell everybody, and I'm telling you guys now, please, that's fine that things happen, right? I mean, right? Sometimes things get so hectic, but please don't, please try to stay with the class. Even if you miss a week, that's okay, right? Because you can try to catch up, or you can sort of right, kind of keep going for the following weeks. So try to stay with the program as much as you can, right? So the reason I'm giving you a lot of exercises, guys, is basically, right? Again, if you look at this, these exercises are very focused. Like, for example, like you can look at NumPy and Pandas. If you go to a search for, I think I have some of them here, right? If you go to NumPy, Pandas, for example, right? If you look at the bottom, I'm giving you guys some extra exercises, right? So for example, if you go here, right, there's like 101 Pandas exercises. Right, so if you really want to get good at Pandas, sure, right? So you can sort of go through this one, but our focus is not to kind of get too sidetracked. We just want to keep you guys focused and keep you guys moving, right? But also at the same time, I don't want to discourage you from let's say if you have some time, right, and you want to kind of right, go spend some time learning Pandas and Python. By all means, please do, right? So that's why right, we are giving you extra pointers if you really want to do it. But usually what I say is, like, if you're pressed for time, at least do a few, just so you can sort of have the basics down. That's it. Yeah. Docker. Do we need to do a Docker? Not really for this course. However, it may not be. It'd be a good skill set for you guys to have. So just do some basic reading up, and maybe you can try running a Docker container. Yeah, but not necessarily for this course. But overall, it's a good skill to have using Docker and Kubernetes. Yeah. All right, guys. So anything else? I'm sorry. Go ahead.
Do we maybe I know for this course that you're teaching a sequence by sequence, like a lecture on machine learning and data science. The thing that I want to know is, does this group ever participate in hackathons or like a Kaggle competitions or other, or are we jumping too far ahead of ourselves for beginners?
Actually, no. I mean, actually, it's one of my plans. Thanks for bringing this up. So let's talk about this. So what I like to do here is, how many people know about Kaggle? It's basically a machine learning competition, right? Right. So they run competitions. So one of the things I like in Kaggle is like, you can actually, they actually publish a lot of data, in a real world data sets. So I would recommend you guys get an account there, even if you're not going to compete, right? But they do some pretty nice competitions if you like, and you can see, right? For example, they're doing like a lift motion prediction, right? So these are pretty advanced competitions, and you can choose your level how you want to compete on. But for me, interesting part is there are some pretty good data, right? So anyway, so get an account there. Either way is a good idea. But we will do some of our own hackathons here in the class. So what I would do, and that's why I'm sort of encouraging you guys to do as sign up into groups. So what we want to do is kind of, when you get into machine learning, we will do machine learning competitions, right? Kind of like not Kaggle, not Kaggle difficult, but for us, right? So every week I kind of want to like do like a little competition, or maybe every other week or something, right? I like to have the teams to compete, right? So this way, it's a little competition going. So it's a healthy competition, right? And also you can learn from each other's algorithms and little tricks. So yeah, we'll definitely do that. Yeah, so that's kind of part of my plan. But I will start small scale. But yeah, I definitely encourage you guys to sign up in Kaggle as well. Yeah. Now, please, okay, so group sign up, right? One more thing, and this is important to you guys. Please find a group to sign up, right? Because I highly encourage you guys to do this, because I kind of want to, going forward, what I like to do is these, like the solutions I'm providing, I like to kind of shift to more toward like group level solution. Like for example, next week I'm just making this up. We have a data and we say, okay, group 1 is going to provide the solutions. So they will kind of work together and publish a solution for all of us. So this way it kind of keeps us motivated, and also kind of distributes the workload for me, because right, I don't want to be the bottleneck for this group. Is that going to make sense, guys? So please find a group. Again, the way people are doing this, again, this is just one way. People are grouping by time zones, right, or geolocation. So you can add your details here, and if you find somebody who's not part of the group, by the way, if you guys are already part of the group, can you actually add this, so this way people know you're already part of a group, right? Kind of say, just put a right, just say group, just so you, oops, right? You can say like group, whatever, right? You can say give your group name, so this way people can know you right away, right? Right, if you're part of a group already, right? And then you can sort of just email each other, kind of again coordinate. You can do email, Slack, whatever, but please be part of the groups, because pretty soon we're going to do competitions, and also you're going to do solutions per group, right? So as you can see, like people are kind of gathering using time zones, basically, because it's easy for them to coordinate.
Okay.
Anyway, yeah. So again, where is all this? Again, in our ubiquitous documentation. If you look at here, somewhere here, where is it? So join a study group, right? So it links
Okay.
here. Yeah.
Okay. I went to the GitHub, but the thing is, I don't think I went to docsgoogle.com. Well, I probably have it open for that, but the thing is, I went to the Git.
Yeah. So basically, this is where you want to be, right?
Okay.
So let me put this link here, guys. So again, right? So if you're here, basically, right, you basically want to be in this document. This has all the links for everything, basically, right? So you don't necessarily, right? And there are tons of links here, right? So I don't recommend kind of bookmark each individual one. Just bookmark this one right here, and then everything here is for you guys. So look at the to-do items specifically. Make sure you're kind of all good on those. And yeah, one of the to-do items is basically join the discussion group, right? Okay.
Okay.
Yeah, definitely.
Before
Yes.
And want to catch up, so it's if we go just through the classes, it will be enough. I mean, because I'm a little confused between the GitHub and the Google classes, and I don't know which one to follow in order to catch up. I just looked at the assignments, as you also mentioned, like that one that was 100 assignments, or practicing. So I don't know how.
Okay. Sure. Okay. Yeah. So let me kind of explain this real quick, and I want to make sure, I'm sure maybe others are wondering too, right? So
we should do the assignments in a
right.
group. And what are the credits? So I have found the credits on the GitHub, but I don't have any clue what's that. I would
Gotcha.
appreciate.
All right, guys. So here's the kind of idea, right? Again, so I mean, again, this is kind of work in progress. So people who, in the class kind of I've been sort of changing things around a little bit just to make it more streamlined. So here's the idea, right? So the GitHub one you're following right here, the one, right? This is the overall machine learning path, right? So kind of I mean, this is sort of the, think of it like a book, basically an open source book, kind of in work in progress, and these are the topics. Now, what I am doing now is like, so this is more like topic based. This is not weekly based. So imagine this is a book, right? So these are the contents we are doing. For example, when you're doing visualization, this is like one chapter of a book, right? And these are the exercises and your reading list and exercise and so on and so forth, right? Now, how I'm distributing the work is basically here, I'm assigning this on a weekly basis, right? Because we only have limited time, right? So what I'm doing now is, right, I'm assigning this on a weekly basis. So for example, you can see the Python section here, right? I had 5 Python sections, but in our weekly, it is sort of split into 2 weeks, right? Because just to kind of how much work we have. Now, if I'm teaching this like a full day class, maybe like a 5-day, 6-day class, right? Then we will do them in like maybe like half a day or something. You know what I'm saying? So this is the overall curriculum, but this kind of outlines how it's broken down on a week basis for us. So hopefully, I hope that made sense. And yeah, so follow this one. So this, again, what is this, right? Look at the curriculum outline, right? So this is where we are going to be actually following on a weekly based curriculum. And usually what I do is I want to share your assignments with others, right? So for that, what I found is we actually submit everything through Google Classroom. Because if we do that, right, I can simply share the class submissions, right? So it's just a Google Drive. I can say here and share with everybody, and you can click on the link, and you can see everybody's submission, right? So that's why. So the only reason we are sort of using Google Classroom is basically to collect the submissions, and then so I can share with everybody, right? Other than that, we are not really using Google Classroom, as it's supposed, because Google Classroom is written for like a traditional classroom where you have 20 students and 1 teacher, and we submit the assignment, the teacher creates it, right? So that model is not going to work for us because we are like about 70 students here, right? So, but still submit using Google Classroom. We may move away from this, but we will see. For right now, people are just submitting assignment to Google Classroom, right? So, if you have any questions, let me know. Ask me on Slack. I'm happy to guide you, right? So again, basic thing is this is sort of the book, right? Think like a little book, and then this is like a weekly breakdown.
And where we should find the assignments? On GitHub or here?
So either way, so the GitHub. So remember, GitHub is just a book, right? So the assignments I'm posting here in the all the way to the end. Every session I'm doing like a summary of the session, right? So for example, last week's session, right? I'm saying, okay, what are the decisions we made, and what are the assignments for this week, right? So you can look at here. So kind of stick to this document because this one is easy for me to update. Does it make sense? I'm sorry if it's a little confusing, but yeah, I hope you guys can follow along on this one. Yeah. And this week I'll post here, right? So I'll say assignments for this week. For this week, they're going to come up, right? 1, 2, right? Does that make sense? Yeah.
Yes.
So keep.
Usually we start the assignments from the scratch, or you also have. I saw some hints, or we should start our own Jupyter notebook,
Yeah, I would recommend. Yeah, I would recommend you guys can start a blank Jupyter notebook and start doing the assignments, right? But when I give you the solution files, I sort of have like I have like a little, right? I sort of follow the process, but you don't have to follow this template. You can just do it on your own. But but if you follow this, so the reason is like for example A1, A2, right? If you follow this a little easier for you to do later, because remember these are notebooks you are doing for your reference, right? So imagine I did a notebook, right? Just some of the best practices, right? Let's say I did a notebook. I have some code here, right? And I sort of had some other code here. Let's say you go and look at this 6 months later, it probably doesn't make a lot of sense, right? So I kind of want you guys to that's why I am doing this as this way, kind of saying, hey, okay, so this is the data. Okay, first question, right? Do a whatever, right? Do a scatter plot, right? So this way, even after go out and look at this few months, it'll kind of make sense what you try to do in this code sample, right? So you can follow this template if you like, but yeah, either way, right? And I've seen people just doing like just plain Jupyter notebooks, and that's completely fine. The whole point is learning, right? I personally like I've seen you guys showing you guys, right? For example, I sort of collect code samples just for my life. For example, let me show you Pandas. This is my Pandas notebook, right? So so this kind of I kind of like the section by section, right? So when I go back and look at this, I know, okay, well, oh, okay, what is this column doing? Okay, I'm doing column selection, right? You guys get the idea, right? So and then yeah. Anyway, you guys get the idea. So do it this way. Just you can download one of my notebooks and kind of start with this, and then add your own code. Good, guys. Any other questions? Anything else? So again, this week assignments. Again, give me a day or two. I'll send this out. Basically, it's going to be along these lines, right? So remember, this week you're going to do a little bit of stats and some data cleanup and possibly EDA. Okay. Yeah. Good, guys. So hopefully, I know we kind of how do you say? We kind of change direction a little, a couple of times because I want to make sure this is easy to follow, right? So if you have any questions, please ask me anytime.
Okay, thanks, Suji.
All right, guys, that's it. So sorry we're a little over. So again, this is the format I'm going to kind of follow. Like each week we'll meet. I'll kind of quickly review the past week assignment, give you guys solution files, answer any questions, right? But again, I kind of want you guys to collaborate on your own. Please join a group. So this way, you're not just limited this, this 1 hour a week or whatever, right? Feel free to, collaborate with your groups. And eventually, I kind of want the groups to build out so, you guys can compete, do like competitions and do like challenges and things like that, right? So definitely join a group. Good, guys, that's it. Thank you so much. Keep an eye on the emails. I'll send out assignments and the recording and everything. Yeah. So thank you.
Thank you.
Thank you.
Thanks, Suji.
Hey, thanks, guys. See you next time.
Thank you.
Excuse me, you are still here?
Sure, yeah, please go ahead.
Thank you. I wanted to ask, what are the other classes you are teaching? You said that you are teaching kind of another Spark class for some companies, but I'm curious to know what else you are teaching.
Oh, yes, sure. Basically, yeah, I run a company called Elephant Scale, and basically what we do is we do. Let me put this link on the window here, chat window here, right? So we teach classes for companies and their teams, right? So most of them tend to be private classes. Our focus is basically AI and big data. So we teach like a lot of machine learning, deep learning, Spark, that kind of classes. Most of our customers are companies, like companies like Cisco, Walmart, and most of our classes tend to be full day classes. Like for example, like this week, I was running a class 5 weeks, like 9 to 5, right? So that's kind of that's our business. So this class I'm doing, this is more of an open source class, right? So it's a free class, so anybody's welcome, and that's why in this case, we can we are doing it on a weekly basis, right? But usually our classes we teach, they are full day classes, like 9 to 5 kind of a thing. Yeah.
Oh, okay, thank you. Yeah, because I saw bunch of different things on your GitHub. That's why, you know, it's
Right. Yeah. Because training is our business. Yeah, we do training, but we also like to do. We also got a lot of requests for individuals, because since most of our training is geared toward companies, we do get a lot of requests for individuals who want to learn on their own. So that's why actually this class you guys are in, this is like a pilot class. So I'm sort of trying out and see how this is going to go. Yeah. So,
yeah, okay. And I saw you have also something NLP with AWS. You also are experts in that area.
yeah, we do a lot of cloud. So I personally know AWS, Amazon, and Google Cloud pretty well. And we have other consultants who know like Azure and everything else. Yeah, so we do a lot of cloud as well. So kind of if I were to sort of see like 3 areas is basically AI, number 2 big data, and number 3 cloud. Those are our focus. Yeah.
Okay.
Yeah.
What I mean, do you recommend for a person who wants to begin on cloud to choose either of these clouds based on your experience and also based on the budget, beginner just for learning? Yeah.
Right. So
and also maybe for future, career, but also,
no, that's a great question. What I would recommend, I mean, are you learning this personally for you? Are you learning for a company?
So I am grad student, so I learn personally, but I don't know which company. But for my internship, I was kind of working on Azure, but it's temporary, so I don't know what they do.
Got it. So okay, so if you're learning personally, I would just pick one cloud and learn, because most of them, once you know one cloud, the rest are very, very similar. I would say like 80-90% similar. So and then if you're a grad student, I'm sure you guys have access to a cloud environment. That could be Microsoft or Google, whoever. You may have free access to the cloud environment. So learn that. So kind of and a lot of them have a lot of tutorials and everything online. So I will start with there. So you don't need to learn all 3 clouds, right? Because that's just too much work. Learn one cloud really well. And the other clouds, when you go to them, you will instantly see the similarities. Like for example, my first cloud was Amazon, because basically all our company infrastructure runs on Amazon, AWS cloud. So I'm pretty good at this. But then I started looking at Google Cloud. I didn't have to spend a lot of time, coming up to speed, because I pretty much knew like what the concepts are and how they're doing it. Because once you're familiar with one cloud, the other cloud environments are very easy to grasp very quickly. So what I would recommend is just do one cloud really well, right? And then kind of so that's one option. Number 2 option is Google Cloud for now is giving out free credits. So I think Amazon stopped doing that. So if you want to learn on your own, that's a pretty good incentive, right? I will go get the free credit and practice, and that credit will last you easily a few months. And you can sort of, and you can go through their courses and try things on your own. That's how I learn. But it's going to have like, if you're going to learn for free, you kind of have to do some, spend a lot of your time, because, there are some videos and things online, but still, you're going to have to end up doing a lot of work yourself. Yeah. And also, I know they provide courses as well, but the courses tend to be a little bit more expensive, right? They probably like $2,000-3,000 per course. But if you want to just learn the basics, you can do so free by following a lot of the tutorials. So shoot me an email or catch me later if you want a little bit more specifics. Yeah, I'm happy to give you some pointers. But basically, advice for now is like whatever cloud you have access to, Microsoft, Google, whatever, start with that, and then learn that concepts really well, and then you can easily learn the other clouds. Does that make sense?
I see lots of people that more interested in Amazon. That's why, and also I got some credits, so I started a little, and I found I don't know, maybe a little more experts and also more people that want to share what they know, and I don't know. Maybe I just came across to that.
Yeah. So
but I'm not sure.
here's the thing. So here's the thing you can have to kind of the way. Okay. So imagine kind of building a house, right? Let's say I'm an electrician. I know how to do the wirings pretty well, right? But that doesn't make me qualified to build a house, because building a house meaning putting all the components together, and right, like it could be electrical, it could be whatever, right? Plumbing, right? So one of the mistakes I see people doing in the cloud is, you just learn just one aspect. What you want to learn is you want to sort of, learn everything reasonably well, so you can build a house. Am I making sense? So you should be able to, you should be, a lot of employees are looking for example, you can go and say, oh, I know like X in Amazon. That's not very useful. But if you say like, I know how to build solutions in Amazon, I'm going to combine X, Y, and Z, that's a valuable skill. Am I going to making sense? Right? What I'm trying to tell you?
Yes, thank you.
Yeah. So always keep this in mind, right? When you learn like little things, you had to always keep a big picture in mind to say, okay, if I want to build a solution on Amazon, what technologies do I need? I'm gonna go learn them. Right. So always think like, right? You're building a house, not like you're not just doing plumbing or electrical work. So you need to kind of learn like a little bit of everything in order for you to build a house. Yeah, that's what I would say. So again, we can, I'm definitely happy to, give you more specific advice if you like. Shoot me an email, or I'm happy to talk to you. Yeah.
Yes, definitely. Thank you so much. Have a good day.
Good, guys. Any other questions, guys? Again, we are done officially, so thanks for sticking around. I know we went a little long today. Any other questions, guys?